Right. Assalamualaikum warahmatullahi wabarakatuh. As for this presentation, my group from BARBAR Steel Sendirian Berhad will be explaining about um, the manual calculation, the design steel that we get from the manual calculation. So the motto of our group is the finest steel has to go through the hottest fire. Alright, from the question given, our group chose case 2. So the following data is also included in our design, which is given in the question given in the question. So first is for us to determine the ultimate vertical load for the roof truss and the RC for the slab, reinforcement concrete for the slab. Alright, for the design action that I get from the roof truss is 1.425 kN per meter square. As for the purlin, would be 0.3375 kN per meter. So by that, we can conclude that for the point load at truss is equivalent to 19.59 kN, and load for purlin would be 1.856 kN. So by that, we can total up for the total load on the truss would be 21.44 kilonewton. So moving on for the slab, before moving on to the slab, we know that as for our group case, there are 6 panels. So the side, how we determine on the design of the truss would be must consist of 6 panels. So as for the slab, for our group we get two-way slab, which is Ly over Lx 7.5 divided by 5.5, so we get 1.36 two-way slab, which is, we can say that it is 3H discontinuous, case 7. Moving on to the permanent action, which is for the first beam, which is 7.43 kN per meter, while the second beam, which is 5.98 kN. For the variable action, 3.96, and for the first beam and for the second beam will be 3.19 kN per meter. So the total design load that we get from both beam, which is for the first beam is 15.97 and the second beam would be 12.86 kN per meter. So let's move on to the steel beam design.
Alright, so in the steel beam design, we're going to use I beam, which is the size of 305 times 102, and the shear force we get is 59.89 kilonewton, and the MED the moment is 112.29 kilonewton. Alright, for our I beam, we use the thickness flange is 10.8 millimeter, and the thickness of web is 6.6 millimeter. Alright, so the resistance shear buckling is doesn't need further check required because Alright, so for the resistance flange buckling, you can see the 44.11 kilonewton is smaller than our 301.95 kilonewton, which is our bending moment resistance. And then for the resistance web buckling is also same. It is fast because 59.89 kilonewton is smaller than 19.75 kilonewton. And then let's for the deflection check, you can see our our deflection is smaller than the max, 11.95 millimeter is smaller than 20.83 millimeter, which is pass.
So we move on to the steel column, which is size 1 to 5 times 1 to 5 times 24 kilonewton meter. You can see. So for the steel column is 1 to 4.21 kilonewton, and for the web and flange, it is from class 1. So for the compression, it is passed because 1 to 4.21 kilonewton is smaller than 8 to 5 kilonewton. And for the buckling resistance, ZZS also passed, which is 1 to 4.21 kilonewton is smaller than 330.5 kilonewton. And the value 1 to 4.21 kilonewton is smaller than 214.5 kilonewton. So we use for the buckling resistance is 330.5 kilonewton. So next we move on to the connection.
So as for connection part, we choose end plate type. So for connection, we assume for the grade, which is 8.8, and the size of bar is M16. Then for standard and steel grade is 2S75, and the thickness of the plate is 10 mm. For the length is 120 mm, and the width is 100 mm. As for plate, we use four holes. So for E1, P2, E1, P1, E2, P2, we assume. We assume the E1, P1, E2, P2, which is E1 is 30 mm, P1 is 40 mm, and E2 is 35 mm, and last one is P2 is 50 mm. For connection part, there are 4 steps, which is ball check, plate check, beam web check, and welding check. So from the positioning of bolt, we can determine the size of the bolt that we use. We can determine the size of bolt that we use is pass or not. Then for the shear resistance, the condition for the shear resistance is actual force must be less than total FVRD. And from the calculation, we can see that for the shear capacity of bolt is pass because the total FVRD is bigger than the shear force. Then for bearing, for shear, for bearing checking, the total FVRD also bigger than the shear force, and it is also pass. For the welding part, the VWRD is bigger than the shear force, which is 209.36 kilonewton, bigger than 1 to 4.21 kilonewton, and it is also pass. And last one is for the for shear resistant beam, the VPLRD is bigger than the shear force, and it is also pass. For the shear resistant end plate, we have to determine the AV first, and we get 1200 nm square, and for the A net is 1040 mm square. So from that, we can get the total VPLRD, which is 381.06 kilonewton, and the total for VRD net is 412.10 kilonewton. So from that we can see that it is pass because the both total VPLRD and total VRD net is bigger than the shear force. As for block carrying, for VEFIRD is bigger than the V column, which is 3 to 8.32 kilonewton, bigger than 124.21 kilonewton, and it is also fast. So, as conclusion for the end plate, we can say that for the overall calculation is passed. So that's all for the steel end plate.
Alright, as for the conclusion, from our group, BARBAR, Cindy and Berhad has chosen optimum size for each steel beam, for steel column, and for steel end plate for its connection. So as we can conclude that the design that we obtain and that after we calculate is very optimum, and do not lead to any wastage. So as from our design, can we zoom a little bit for the picture? The top part. The top part of the picture. Alright, so we can see that there are 6 panels, which is from the question. From the question we gain keys 2, so which consists of 6 panels, and this is our design, and the length for the design would be 4 times, which is something that required from the question. So as a group, we know that we already fulfill the requirement that is needed from the question. That's all from us. Thank you.